2 in the morning in Tokyo, and the city is as quiet as a city of 37 million people ever gets. Then, all at once, from Adachi Ward to Yokohama, from Chiba to Saitama, every phone in every dark bedroom starts to scream. Not one phone, not a neighborhood, tens of millions of them, at the same instant, in the same rising two-tone shriek that every person in Japan learns to fear before they learn to drive. And here is the part that tells you what kind of country you are watching. The screaming came first, the shaking came second. Somewhere under southern Ibaraki Prefecture, a piece of rock had already broken, and a machine had already worked out what was coming, and had already told 37 million sleeping people about it before the ground under their beds began to move. What happened next left at least 37 of them injured in 5 prefectures, flooded a street in Koto Ward with water from a burst main, and stopped trains across the Kanto plain. And then, 20 hours later, Japan shook again, 680 kilometers to the north, in a place that had not produced an earthquake this size in 10 years. 2 events, 1 day, 1 country. In this video, I am going to show you exactly what broke, why the deepest part of this story is the part almost nobody is reporting, and whether these 2 quakes have anything to do with each other. That last answer is going to surprise you, and I am not going to give it away yet. If you want the honest version of events like this one, fast, without the doom and without the hype, this channel exists for that. Subscribing takes a second and it means the next one reaches you. So let's start with what is measured, because that is where every real story starts. The Japan Meteorological Agency assigned the first earthquake a preliminary magnitude of 5.9. The United States Geological Survey, working independently with its own instruments and its own maths, came in slightly lower at 5.8. That gap is normal, and it is not a controversy. It is just 2 agencies using different scales on the same event. The epicenter sat in the southern part of Ibaraki Prefecture, near the towns of Toride and Ryugasaki, which puts it about 40 kilometers from the northern edge of the Tokyo metropolitan sprawl. The timing was 2 in the morning on Sunday, the 23rd of August, 2026. And then there is the number that explains almost everything else about this event: depth. Between 68 and 70 kilometers, according to the Japan Meteorological Agency. Some catalogs put it a little shallower, closer to 60. Take the middle of that range and hold it in your head, because it is going to come back. 68 kilometers straight down is a hard thing to picture, so let me anchor it. The deepest hole human beings have ever drilled into the planet, the Kola borehole in northwestern Russia, reached about 12 kilometers before the rock got too hot and too plastic to keep going. This earthquake happened more than 5 times deeper than the deepest hole we have ever managed to dig. It was not a crack in the crust under a Japanese suburb. It was something breaking far below the crust entirely. On Japan's Shindo scale, which measures shaking where people are standing rather than energy at the source, the strongest reading was lower 5. That was recorded in Tokyo's Adachi Ward and in parts of Ibaraki, Saitama, and Chiba prefectures. Level 4 came in across other parts of Tokyo and in Tochigi, Gunma, and Kanagawa. The agency's own plain language definition of lower 5 is worth hearing, because it is not abstract. Objects fall from shelves, and most people need to grab hold of something to stay steady. It is the level where a room stops being furniture and starts being a set of projectiles. The shaking lasted, in some areas, up to a full minute. Sit with that duration for a moment against your own experience of these things. Most earthquakes people remember lasted 10 or 15 seconds. A minute of continuous motion, in the dark, at 2 in the morning, after your phone has already told you it is coming, is a very long time to be awake and horizontal and unable to do anything about it. Which brings us to the injuries, and to the first place where the honest version of this story separates from the loud version. Japan's Fire and Disaster Management Agency, compiling reports from prefectural governments, counted at least 37 people injured. The breakdown was 15 in Tokyo, 9 in Saitama, 8 in Kanagawa, 4 in Chiba, and 1 in Ibaraki. One of those injuries was serious. In Yokohama, a woman in her 80s fell from her bed and suffered a severe hip injury, according to reporting in the Yomiuri newspaper. One building was damaged in Saitama Prefecture. Now read that list again and notice what is missing from it. No collapsed houses, no people pulled from rubble, no fatalities. Officials were direct about the cause of almost every one of those 37 injuries, and it was not falling masonry. Most of them were people who fell or who hit themselves against furniture or doors while getting out of bed in a panic in the dark. This is a detail that gets flattened in the headlines, and I think flattening it does everyone a disservice. A magnitude 5.9 earthquake 68 kilometers below the ground did not throw 37 people around. The clock did. If this exact same earthquake had happened at 2 in the afternoon, the injury count would almost certainly have been a fraction of what it was, because those people would have been upright, awake, and not sprinting through a dark bedroom on adrenaline 3 seconds after an alarm woke them. One young man described the sequence precisely. His alert went off, he felt a vertical jolt, and then the building around him started to move, and what frightened him was the merchandise on the shelves above his head. That is the real hazard profile of a nighttime earthquake in a well-built city. Not the building, the bedroom. What did break was infrastructure. And in one specific place, it broke visibly. A water main ruptured in Tokyo's Koto Ward, and by the small hours of Sunday morning, first responders from the Tokyo Fire Department were standing in a partially flooded street in a photograph that went around the world faster than any of the official figures did. Buried pipes are one of the quietest vulnerabilities in any old, dense city, and they fail at shaking levels far below what it takes to threaten a modern building. The rail network responded the way it is designed to. Some services started late, some ran at reduced speed, some express trains serving Tokyo and Narita Airport were delayed, and certain Tobu Railway express services were halted outright. The Shinkansen ran normally. That is not luck. Japan's bullet trains are wired directly into the same detection network that woke everyone up, and they break automatically on the warning rather than on the shaking. There is one more measurement from this earthquake that I want you to know about, because it is the kind of thing that only shows up in the technical bulletins, and it matters more with every tower Tokyo builds. Long-period ground motion was observed in the city of Kawaguchi in Saitama, in Urayasu in Chiba, and in Tokyo's Koto and Edogawa wards. Long-period motion is the slow, rolling, almost seasick component of an earthquake, and short buildings barely notice it. Tall ones do. A skyscraper has a natural sway rhythm, the way a wine glass has a note, and when the ground rolls at a period close to that rhythm, the building can amplify the motion instead of resisting it. People on the 40th floor can feel something close to a boat in a swell, while people on the pavement outside feel a jolt and nothing more. Every one of those 4 locations sits on soft, reclaimed, water-heavy ground on the Tokyo Bay lowlands, which is exactly where those long, slow waves get magnified. In the village of Tokai in Ibaraki Prefecture, home to the Tokai and Tokai No. 2 nuclear plants, shaking registered at Shindo 3. The Japan Atomic Power Company reported no abnormalities at Tokai No. 2, which has been offline for an extended period, and said checks were continuing at the Tokai plant, which is being decommissioned. Within an hour, Prime Minister Sanae Takaichi had posted that impact assessment was underway and that a liaison office had been opened at the Prime Minister's Office Crisis Management Center. She confirmed the quake had been felt across the capital, and in Ibaraki, Saitama, and Chiba said authorities were taking appropriate measures and asked residents in the areas of strongest shaking to stay alert for the possibility of another earthquake of similar size. A government task force was established to assess the extent of possible damage. So that is the event. Now here is the question that actually makes this earthquake interesting, and it is a question almost nobody asked in the first 24 hours. Why was it 68 kilometers deep? Because that is not where earthquakes under a continent are supposed to happen. The crust under a place like the Kanto plain is roughly 30 to 40 kilometers thick. Below that, in most of the world, rock is warm enough and soft enough that it flows rather than snaps, and things that flow do not produce earthquakes. An earthquake at 68 kilometers under a major city should be nearly impossible. Under Tokyo, it is routine. And the reason is a piece of geology so unusual that there is exactly one other place on Earth like it, which is to say, there is nowhere else. About 150 miles southeast of Tokyo, out under the Pacific, three tectonic plates meet at a single point. Geologists call it the Boso Triple Junction, and it is the only known trench junction on the planet. The Philippine Sea Plate is diving down beneath the continental plate that Tokyo sits on. At the same time, the Pacific Plate is diving down beneath both of them. Two oceanic plates going down into the same slot at different speeds and different angles, one underneath the other, with a city of 37 million people built on the lid. Forget faults as lines for a moment. Think of three heavy stone sliding doors jammed into a single track, overlapping, each being pushed by something enormous and patient, each grinding along the face of the one behind it. Most of the world's subduction zones have one door. Kanto has three in the same groove, and the noise they make is earthquakes. Researchers working on this region have a specific name for what it produces: anomalously deep interplate and intraslab earthquake activity, seismicity that occurs far below where it has any business occurring, because the contact between the Philippine Sea slab and the Pacific slab underneath it drags the brittle, breakable zone down to depths that a normal subduction zone never reaches. Clustered swarms, deep focus shocks down past 160 kilometers, and a long history of large events above magnitude 7. That is what happened on Sunday morning. Not a crack in the ground under Ibaraki. A break in a slab of ocean floor being crushed between two other plates, 42 miles beneath the suburbs, in the strangest tectonic arrangement on Earth. And that depth did two things at once, in opposite directions. It saved lives, and it spread the shaking. Energy released 68 kilometers down has to travel a long way to reach anyone, and it weakens as it goes, which is the single biggest reason a magnitude 5.9 right beside the largest metropolitan area on the planet produced burst pipes and bruised shins instead of collapsed buildings. But because that energy comes upward and outward from so far below, it arrives across an enormous footprint. 7 prefectures felt level 4 or stronger. A shallow quake of the same size would have hammered one small district and left the rest of Kanto barely aware of it. This one was gentle everywhere and severe nowhere, and everywhere is a lot of people. One seismology service running an automatic first-order calculation estimated the ruptured patch of rock at around 63 square kilometers, with a rupture length of roughly 14 kilometers. 14 kilometers. Shorter than a lot of people's daily commute. That is the entire tear in the earth that woke a metropolis, and I find that ratio between cause and consequence hard to get used to no matter how many of these I cover. Now, 20 hours later, at about 10:45 on Sunday night, with Kanto still absorbing the morning, alarms went off again, this time in the north. A magnitude 6.0 earthquake struck off the coast of Urakawa on the southern shore of Hokkaido at a depth of about 40 kilometers. Maximum shaking reached Shindo 4 in the Hidaka region. Intensity 3 was recorded across a wide area, taking in eastern, central, and southern Hokkaido and reaching down the Pacific coast of the Tohoku region. No tsunami warning was issued, and no casualties or damage were reported. The United States Geological Survey estimated that around 1.9 million people felt light shaking and 3.4 million felt weak shaking, and issued a green alert, its lowest for expected fatalities and economic loss. On paper, that is a smaller story than the morning. Fewer injuries, meaning none. Lower Shindo, a rural coast instead of a capital. But there is a fact buried in the Japanese bulletins that makes the Hokkaido event the more unusual of the two, and it is this. An earthquake of magnitude 6.0 or greater has not occurred in that specific patch of seafloor off Urakawa since January of 2016, 10 years. And it had been about a year since any earthquake from that source produced Shindo 4 or higher anywhere. This was not a routine rattle in a place that rattles constantly. It was a source area waking up after a decade of relative quiet. The mechanism has already been worked out from the wave patterns. It was a reverse fault earthquake, with the compression axis running from north-northwest toward east-southeast in an area where the Pacific plate is subducting beneath the continental plate. It is thought to have occurred near the plate boundary itself, and the bulletin carried a specific, geographically limited caution. Further earthquakes of similar size may occur in coastal areas close to the epicenter, particularly around the Hidaka region and off Urakawa. That word Hidaka is worth stopping on because the Hidaka region is one of the strangest pieces of geology in Japan. It is a collision zone. It is where the Great Arc of Hokkaido is being shoved into itself, mountains being manufactured in real time by two crustal blocks refusing to yield, and this coastline has form. In March of 1982, an earthquake struck almost exactly here, magnitude 7.1 on the Japanese scale, rupturing along the Hidaka collision zone at a depth of about 44 kilometers. It injured 167 people and generated a small tsunami of about 1.3 meters at Urakawa itself. The rupture that did all of that was only about 12 kilometers by 22 kilometers. So Sunday's quake happened in the neighborhood of a fault system with a proven capacity to do far more than it did. That is the honest context for a Shindo 4 event that hurt nobody. Which brings us to the thing you have been waiting for since the first minute of this video. 2 earthquakes, 1 day, 1 country. Are they connected? No. And I want to give you the reasons rather than just the verdict, because the reasons are more useful than the answer. Start with distance. The Ibaraki epicenter and the Urakawa epicenter are separated by roughly 680 kilometers, a little over 400 miles. That is New York to Cleveland. It is London to Edinburgh with distance to spare. Earthquakes do influence each other through stress transfer, and that is real physics, not hand-waving. But the effect falls away with distance at a brutal rate, and it operates over a few rupture lengths, not over hundreds of kilometers. The Ibaraki rupture was about 14 kilometers long. 680 kilometers is roughly 50 times that. Then look at the mechanisms, because they are not even the same kind of event. The Ibaraki earthquake happened at 68 kilometers depth inside the tangle of the Boso Triple Junction, where the Philippine Sea slab and the Pacific slab are grinding against each other beneath a continent. The Urakawa earthquake happened at 40 kilometers depth on the Pacific plate boundary beneath Hokkaido as reverse faulting under north-northwest compression in a collision zone that builds mountains. Different plates in contact, different depths, different stress orientation, different geology entirely. Calling them one event because they share a calendar date is like calling 2 thunderstorms on opposite sides of a continent the same storm because it rained on Tuesday in both places. And then there is base rate, which is the least dramatic and most important thing in this entire video. Japan records more than 1,500 earthquakes a year that people actually feel. That is 4 a day, every day, on average. In the specific area around that Ibaraki epicenter, one catalog drawing on more than a century of records puts the long-run average near 3,700 earthquakes a year of all sizes. In the 72 hours before Sunday, Japan logged a magnitude 5.4 off Chiba, a magnitude 4.4 near Iwaki in Fukushima, a magnitude 4.4 near Naze in Kagoshima, a magnitude 4.7 off Okinawa, and small shocks around Kumamoto. None of those made international news. In a country with this level of background activity, 2 moderate earthquakes in 20 hours in different regions is not an anomaly demanding an explanation. It is a Sunday. The same applies to the warning that is being quoted everywhere. The Japan Meteorological Agency asked people in the strongly shaken areas of Kanto to stay vigilant for about a week against another earthquake of similar size, and the Prime Minister repeated it. That is being reported in some places as if Japan has predicted an earthquake. It has not. Nobody can. What that advisory reflects is a statistical property of earthquakes that has been known for well over a century. After any event of this size, the chance of another one nearby is temporarily elevated above normal, and it decays over days to weeks. The agency issues that same guidance after essentially every event in this magnitude range. After the far larger Kumamoto earthquake in July, it warned of possible Shindo 7 shaking for 2 to 3 days. It is a protocol, not a prophecy, and understanding that difference is the difference between being prepared and being frightened. You will also see posts right now tying these two quakes to the Nankai Trough. Let me be exact about this, because the exaggeration and the reality are both worth knowing. There is no official warning connecting Sunday's earthquakes to Nankai. What exists is a long-term government hazard assessment, which puts the probability of a magnitude 8 to 9 earthquake along the Nankai Trough at somewhere around 70 to 80% within 30 years. That estimate is real, it is sobering, and it has nothing to do with what happened on Sunday. It was the same number last month, and it will be the same number next month. A deep quake under Ibaraki and a plate boundary quake off Hokkaido do not move it. Now, having taken all of that away, let me tell you what genuinely is notable here. Because there is something. It is context. And the context is July. On the 28th of July, 2026, an earthquake with a Japanese magnitude of 7.1 and a moment magnitude around 6.8 struck Kumamoto Prefecture in southern Japan at a depth of roughly 10 to 16 kilometers. It produced Shindo 7, the very top of the scale, in Uki City and Hikawa Town. It ruptured the ground at the surface along the Hinagu Fault Zone. An explosion tore through the Aeon Mall in Kashima about 80 minutes after the shaking, bringing down part of the second floor with workers still inside. Around 3,000 shoppers had already been evacuated to the car park. A chimney collapsed at a Nippon Paper Industries mill in Yatsushiro. At least 38 people were confirmed dead and more than 350 injured, with one death attributed to heat stroke in a car during the 36-degree heat that followed. More than 390 aftershocks were recorded. Hold the energy comparison in your mind, because it explains a great deal about the mood in Japan right now. Each full step up the magnitude scale is about 32 times more energy released. The gap between 5.9 and 7.1 is more than a whole step. The Kumamoto earthquake released something on the order of 60 times the energy of Sunday morning's quake in Ibaraki. 60 times. And it was shallow, and it was under a fault at the surface, and that is why one killed 38 people and the other burst a water pipe. But every person in Kanto who woke to a screaming phone at 2 in the morning on Sunday had watched those Kumamoto pictures 4 weeks earlier. That is the part the numbers cannot capture. This was not a magnitude 5.9 arriving in a calm country. It was a magnitude 5.9 arriving in a country that had just buried 39 people in a month that had already been busier than usual, at the hour when the human body is least able to make a good decision. The shaking was moderate. The fear was not, and I do not think the fear was irrational. So what happens next, and what should you actually watch? 3 things. First, the Kanto window. The Japan Meteorological Agency's roughly 1-week vigilance period for southern Ibaraki runs to about the 30th of August. Watch whether the aftershock sequence follows the standard pattern of decay, fewer and smaller events as the days pass, or whether it does something less obedient. Aftershocks from a rupture of that size are expected within about twice its length of the epicenter, which puts the zone to watch inside roughly 30 kilometers. If the region simply goes quiet through the end of the month, that is the story ending in the most boring and most welcome way there is. Second, Hidaka and Urakawa. This one I would watch more closely than the Tokyo event, and almost nobody is. The bulletin specifically flagged the possibility of further similar-sized quakes near that epicenter, and that source area had been quiet for a decade before Sunday night. A single magnitude 6.0 after 10 years might be one release and nothing more. A cluster there would be a different conversation. And the 1982 earthquake on that same collision zone is the reason it would be a different conversation. Third, the slow number nobody watches. Japan's deep monitoring of the Boso Triple Junction is continuous, and it is the only place on the planet where we can study a trench collision with modern instruments. Every deep Kanto earthquake like Sunday's is a data point about how those two stacked slabs are actually interacting 60 and 70 kilometers beneath a metropolis. That work does not produce headlines. It produces the models that determine what Tokyo's building codes look like in 20 years. Here is what I would ask you to take from all of this. The most impressive thing that happened in Japan on Sunday was not either earthquake. It was that 4,235 seismometers, wired into a single network across a country roughly the size of California, detected a rupture 42 miles underground, calculated where the damaging waves were heading, and put an alarm into tens of millions of pockets before those waves arrived. That is one instrument for every 90 square kilometers of Japanese territory. It is the most sophisticated seismic warning system any society has ever built, and on Sunday morning it worked exactly as designed at 2 in the morning for 37 million people who were asleep. Nobody died. In a country that lost 39 people to an earthquake 4 weeks ago and 732 to 1 on New Year's Day 2 years earlier, that is not an accident and it is not luck. It is engineering, code enforcement, drills done in primary schools, and a warning network that pays for itself in a single minute. Have you ever been woken by an earthquake? That specific, horrible confusion of not knowing yet whether to run? Tell me where you were in the comments. I read them. And the ones from people who have lived through this teach me more than the bulletins do. The window closes around the 30th of August. That is the date the Japan Meteorological Agency's Kanto advisory runs out, and it is the date I will be watching the Hidaka coast as well, because a source that has been silent for 10 years does not always speak only once. If either region moves again, I will have the numbers here before the wire services do. Subscribe and turn on the bell if you want the next one to reach you at the moment it matters rather than 3 days later, because on a planet this restless, there is always a next one, and the only real question is which coastline it belongs to.